This is the 2018 MEXT College of Technology Mathematics paper. Let's begin. Section 1, Number 1. First, if a cubic equation has a constant term, we can consider its factors. So plus 2 is either 1 times 2 or minus 1 times minus 2. So let's try substituting plus 1 into this equation. 1 plus 1 minus 4 plus 2. And this is equal to 0. This means that x minus 1 is a factor. So let's try dividing this polynomial by x minus 1. X squared times x is x cubed. X squared times minus 1 is minus x squared. X squared minus x squared is 2x squared. Plus 2x times x is 2x squared. Plus 2x times minus 1 is minus 2x. Minus 4x minus 2x is minus 2x. Minus 2 times x is minus 2x. Minus 2 times minus 1 is plus 2. So this equation is equal to x minus 1 times x squared plus 2x minus 2. Now, let's use the quadratic formula to solve this part. Therefore, the solutions are plus 1 and minus 1 plus or minus root 3. Section 1, Number 2. Recall that cosine 2x is 2 cosine x squared minus 1. Now, because this is a quadratic equation, we can use the quadratic formula to solve this. So now we know that cosine x is equal to minus 1/2 and minus 1. When cosine x is minus 1/2, remember the graph of cosine. Cosine x is positive 1/2 when x is pi over 3 or 60 degrees. So we basically have to consider pi minus pi over 3 and pi plus pi over 3. So cosine x is equal to minus 1/2 when x is either 2 pi over 3 or 4 pi over 3. Next, when cosine x is minus 1, we should be here in this graph. So x should be exactly pi. So these are the three solutions: 2 pi over 3, 4 pi over 3, and pi. Section 1, Number 3. Let's pay attention to the first term. This is equal to 3 times 3 to the power of 2x, because a times a to the power of x is a to the power of x plus 1. Next, 3 raised to the power of 2x is 3 raised to the power of x squared, because a raised to the power of b times c is a raised to the power of b raised to the power of c. Therefore, this equation can be rewritten as follows: 3 times 3 raised to the power of x squared plus 5 times 3 raised to the power of x minus 2 equals 0. Now, once again, this is a quadratic equation, so we can use the quadratic formula to solve this equation. So 3 raised to the power of x is 1/3 or minus 2. In the former case, x must be minus 1, because 3 raised to the power of minus 1 is 1/3. In the latter case, there is no solution, because if you remember the graph of exponential functions, the graph is entirely above the x-axis. So x equals minus 1 is the only solution. Section 1, Number 4. Just like in the previous question, we need to modify the first term so that it is expressed in terms of 2 raised to the power of x. So 4 raised to the power of x plus 1 is 4 times 4 raised to the power of x. And 4 is 2 squared. So this is equal to 4 times 2 raised to the power of x squared. So let's rewrite this inequality. Once again, this is a quadratic equation. So let's use the quadratic formula. So 2 to the power of x is 1/4 or minus 3. In the former case, x is minus 2, whereas in the latter case, there is no solution because 2 to the power of x cannot be negative. Therefore, x has to be greater than or equal to minus 2. Section 1, number 5. Recall that log a raised to the power of b is b times log a. So the exponent 4 can be moved to the front. Next, let's use the change of base rule to change the base 4 to base 2. Now, since 4 is 2 squared, log base 2 of 4 is log base 2 of 2 squared, which is 2. So the right-hand side becomes 2 log base 2 of x. Now, let's move the term on the right-hand side to the left-hand side. The left-hand side can be factorized. Therefore, log base 2 of x is 0, or log base 2 of x is 2. In the former case, x must be 1. In the latter case, x must be 4. So the solutions are x equals 1 and x equals 4. Section 1, number 6. Recall that log base a of b plus log base a of c is equal to log base a of b times c. So the left-hand side becomes log base 3 of 3 minus x times x plus 1. Because log base a of a is 1, the number 1 can be expressed as log base 3 of 3. Therefore, minus x squared plus 2x plus 3 is less than 3. So, we know that x is less than 0 or greater than 2. We also know that log base a of b implies that b is greater than 0. Therefore, 3 minus x is greater than 0, and x plus 1 is greater than 0. So, x has to be greater than minus 1, and x has to be less than 0, and x has to be greater than 2, but less than 3. So, x is between minus 1 and 0, and between 2 and 3. Section 1, number 7. Let x be equal to the magnitude of 2 vector a minus 3 vector b. Now, square both sides. Now, note that the square of the magnitude of x times vector a plus or minus y times vector b is equal to x squared times the magnitude of vector a squared plus or minus 2 times x times y times the dot product of vector a and vector b plus y squared times the magnitude of vector b squared. Therefore, x squared is equal to 4 times the magnitude of vector a squared minus 2 times 2 times 3 times the dot product of vector a and vector b plus 9 times the magnitude of vector b squared. Since the magnitude of vector a is 1, the first term becomes just 4, and the dot product of vector a and vector b is 2. So this is equal to minus 24, and plus the magnitude of vector b is 3. So 9 times 9 is 81, which is equal to 61. So x is plus or minus root 61. But because x is the magnitude of a vector, x cannot be negative. So the answer is plus root 61. Section 1, number 8. Now, because the line L passes through the intersection of these two lines, let's find the coordinates of the point of intersection. I'm going to multiply both sides of the first equation and substitute this value of x into the first equation. So the point of intersection between these two lines is at 1, 2. Now, we are also told that line L is perpendicular to this line. So let's find the slope of this line. If two lines are perpendicular to each other, the product of the two slopes must be equal to minus 1. The slope of L must be minus 2. So what is the equation of a line with the slope of minus 2, which goes through the point 1, 2? The answer is y equals minus 2x plus 4. Section 1, number 9. The nth term, a sub n, can be expressed as the sum of n terms minus the sum of n minus 1 terms. For example, let's say that we want to find the fourth term. All we have to do is to subtract 1 plus 2 plus 3 from 1 plus 2 plus 3 plus 4. Therefore, 3n plus 2n minus 1 minus 3n minus 1 plus 2n minus 1 minus 1. Now, because 3 to the power of n is 3 times 3 to the power of n minus 1, first term becomes 3 times 3 to the power of n minus 1, and the first two terms can be factorized. So this is the answer. Section 1, number 10. We need to modify what's inside these brackets. To do so, we make use of the following fact. A minus b times a plus b is a squared minus b squared, by treating this whole root as one term. So multiply this by root x squared plus 3x plus 4 plus x, and don't forget to divide this by the same thing. So the numerator becomes x squared plus 3x plus 4 minus x squared. Next, we're going to make use of the fact that x is equal to root x squared. So divide both the numerator and the denominator by 1 over x. So now, let's calculate the limit as x approaches infinity. Recall that as x approaches infinity, 1 over x becomes 0, and 1 over x squared becomes 0, and so on. So these numbers will disappear. So the answer is 3 over 2. Section 1, number 11. Recall that log base a of b times c is log base a of b plus log base a of c. Therefore, f of x is log base e of x plus log base e of x plus e. Next, let's differentiate this function. Log base e of x is 1 over x. Log base e of x plus e is 1 over x plus e. So finally, to find f dash of e, let's substitute e. So 3 over 2e is the final answer. Section 1, number 12. In this question, we're going to use a technique called integration by parts using the following formula. So first, let u be equal to x. du dx is 1. So du is equal to dx. Next, let dv be equal to cosine x dx. So dv dx is cosine x. So v is sine x. So u x times v sine x minus v sine x and du dx. Now the integral of sine x is minus cosine x. So plus cosine x. And sine pi over 2 is 1. Cosine pi over 2 is 0, and cosine 0 is 1. So this is the final answer. Section 2, number 1. So to find a, we're going to use the first condition, which states that b squared is b. So b squared is b times b. A times a, minus 2 times 1, a times minus 2, minus 2 times 2. 1 times a, 2 times 1, 1 times minus 2, and 2 times 2. So minus 2a minus 4 must be equal to minus 2, which means a is minus 1. Next, the second condition states that b times c is equal to c times b, which is equal to this matrix. Minus 1 times b, minus 2 times minus 1, minus 1 times 2, minus 2 times minus 1, 1 plus b, 2 plus minus 1, 1 times 2, 2 times minus 1. Therefore, minus b plus 2 must be 0. Therefore, b is 2. Section 2, number 2. We are told that a is equal to x times b plus y times c. Now, because x and y are scalars, we can multiply each of these elements by x and y. Minus x plus 2y, minus 2x plus 2y, x plus minus y, 2x plus minus y. Therefore, minus 1 is equal to x minus y, and 0 is equal to 2x minus y. And let's solve these equations simultaneously. So x is 1. Let's substitute this value of x into the first equation. So x is 1 and y is 2. Section 2, number 3. So first of all, let's start with a squared. What's a cubed? Next, what is a to the 4th power? So let's figure out the pattern. 7 times 2, 14 plus 1. 15 times 2, 30 plus 1. So 31 times 2, 62 plus 1, 63. 6 times 2, 12 plus 2, 14. 14 times 2, 28 plus 2, 30. 30 times 2, 60 plus 2, 62. Minus 3 times 2, minus 6, minus 1. Minus 7 times 2, minus 14, minus 1. So minus 15 times 2, minus 30, minus 1, minus 31. Minus 2 times 2, minus 4, minus 2. Minus 6 times 2, minus 12, minus 2. So minus 14 times 2, minus 28, minus 2, minus 30. And this is the answer. Section 3, number 1. We need to find the maximum of f of x. In order to do so, we need to differentiate f of x. Let's use the quotient rule because f of x is a fraction. So remember the quotient rule. If f of x is u over v, then f dash of x is u dash v minus u v dash over v squared. In this case, u is log base e of x, so u dash is 1 over x, and v is x, so v dash is 1. F dash of x is 1 over x times x minus log base e of x times 1 over x squared, which is 1 minus log base e of x over x squared. When f dash of x is 0, minus 1 log base e of x over x squared is 0. 1 minus log base e of x must be 0. Log base e of x is 1. Therefore, x is e. Let's substitute this value of x into the original function. Log base e of e is 1. Therefore, the maximum of f of x is 1 over e. Section 3, number 2. So the tangent line L goes through the origin. Let the point of tangency be called P with the coordinates P and Q. So first of all, the slope m of the tangent line can be expressed as Q minus 0 over P minus 0, or simply Q over P. The slope can also be expressed as f dash of P, which is 1 minus log base e of P over P squared. Therefore, Q over P is equal to 1 minus log base e of P over P squared. So let's express Q in terms of P. Q is f of P, so log base e of P over P. So the left-hand side becomes log base e of P over P over P, which is log base e of P over P squared. So log base e of P is equal to minus 1 log base e of P, meaning 2 times log base e of P is 1. So log base e of P is 1/2. This implies that e to the power of 1/2 is P. So what is Q? Remember, Q is f of P. So f of e to the power of 1/2 is log base e of e to the power of 1/2 over e to the power of 1/2. So Q is 1 over 2 times e to the power of 1/2. Finally, let's find the equation of the tangent. Let's use the first equation. The slope m is log base e of e to the power of 1/2 over e to the power of 1/2 squared. So y equals 1 over 2e times x is the equation of the tangent L. Section 3, number 3. In this question, we need to find the area bounded by line L, function f of x, and the x-axis. So we basically have to calculate the area of this green triangle and then subtract the area under the curve here. So green triangle minus the area under the curve. So let's consider the green triangle first. The area of the triangle is 1/2 times e to the power of 1/2 times 1/2e to the power of 1/2. So 1/4. Next, let's find the area under the curve. The function f of x intersects the x-axis when x is equal to 1. So we need to find the area under the curve between 1 and e raised to the power of 1/2. To do so, we're going to use a technique called integration by substitution, or u substitution. So let u be equal to log base e of x. Du dx is 1/x. Therefore, du is 1/x dx. So this is equal to u times du. Recall that u is equal to log base e of x. So u squared is log base e of x squared. This is equal to 1/8. Therefore, the area S is 1/4 minus 1/8, which is 1/8. And this is the final answer. This is the end of this exam paper. See you next time.